Hi, welcome to Code. In this video, we'll be solving a question called number of islands, and this question has been asked in FAANG companies. It's from LeetCode, and we'll solve this in this video. So, in the question, we are given a binary matrix. So, what do I mean by a binary matrix? The elements in this matrix are either 0 or 1. So, that is why we are calling it a binary matrix. So, what they are given is, if the element is 1, it is considered land. Okay, so if it is 0, it is considered water. So that basically is it. So we are given a matrix which is a binary matrix, so it has only ones and zeros, and the ones in the matrix are considered land and the zeros in the matrix are considered water, and you are required to find the number of islands in this matrix. Okay, so that basically is what the question is. So I am required to find the number of islands. So if we can reach an element through land with the 4 basic types of motion, so you can move forward, backward, left or right. So these are the motions that are allowed here. And if you can reach any ones in the, if you can reach any one or the land area in the matrix by these 4 motion, it is also considered a part of this island. Okay, so you are supposed to find the total number of islands or the number of disconnected land areas, you can say. Okay, so in this particular example, you are given a matrix with 4 rows and 5 columns. Okay, so here if we see, the 0, 0 position has a 1, and if you can move to the right of it, you have another 1, and you can move to the right of it, we have another 1, you can move to the right of it, we have another 1, we can move to the bottom of that one, we have another 1 as well. So all these comes under the first island. Okay, because you can travel to all these ones with the basic motions, that is forward, backward, left or right, from the first element. So all these comes under a single island, and we are not finished yet. So from the first number, the first index or the first character of the matrix, I'm just repeating again and again at this point. So from the first character of the matrix, you can also travel towards the down of the matrix, towards the bottom of the matrix, and we have 1, and from that one you can go either to the right or to the left, and if we go to the right, you can also go down. So all these ones can be traveled from the first character of the matrix only by the 4 basic motion directions. So from backward, front, left or right. With these motion, you can travel all the ones in the matrix. So it means there is only one single island in the whole matrix. So the output should be 1. Whereas in the other case, or the second example, we have a similar matrix with 4 rows and 5 columns. But here you can see there is a 2 cross 2 1 matrix. There is a 2 cross 2 matrix formed at the first 2 rows and first 2 columns. Okay, that has ones, and it is surrounded by water in every other area. Okay, or it doesn't have anything else, that is to the top and left, it doesn't have anything else, and it is surrounded by water in every other part. So this particular cluster is a single island, and we have another one here in 3 cross 3 position, which is also separated because for that one the above element is 0, to the left it has a 0, to the right it has a 0, to the bottom it has a 0. So it is surrounded by water in all 4 positions. So that is an island as well. And at the last row we have the last 2 columns as 1, and that is surrounded by water in 2 directions, that is above and left, and to the right there is no other element, to the bottom there is no other element. So we have 3 islands in this matrix. So I hope you understand what the number of islands in the matrix means by now. We have seen a couple of examples, so you should have a basic idea of what this is. Now I'll tell you what the approach is, what we are going to do in this program, and we'll try and code this now. So what we are going to do is, we are going to traverse this matrix element by element. So the row wise, and we'll see if that particular element is a 1 or the land area. So if that particular element is a land area, we'll increment the number of islands that we have. So we'll have another variable for that, and we'll increment that. The number of island has been incremented. After this, what we'll do is we'll travel to every single element in the matrix that can be reached from this particular character or this particular land area, whichever the area that we can travel from this particular point, and if it is a 1, we'll mark that as 0. Okay, so what this will do is this will make all the land area that is accessible from this land area as water. So the rest of the islands will not count these areas. Okay, so I think I'm making sense here, or I'll just repeat that. So we are going to traverse the matrix character by character, that is the row wise, so with the help of a nested loop, and we are going to see if a particular character in that matrix is 1. That means it is a land area. What we'll do that is we'll increment the value of number of islands element, I mean the variable. We'll increment the value of number of islands, and we'll traverse in every direction from that particular land area and mark everything that is accessible as 0. Okay, we'll mark every other land area from that land area to 0, the elements that are accessible from that land area to 0. So what this will do is this will enable us to count the number of islands without any duplicates. So since we are traveling by element and seeing if it is a 1, the elements that are accessible from first island should be marked as 0. So we are just marking our flag or our territory there so that it has been counted already. We are just telling that it is counted already, you don't have to worry about that. So we are traversing element by element and seeing if it is a 1. It means that it is a land area. You are incrementing the value of number of islands and marking everything that is accessible from that island to 0. So if you are not completely satisfied or if you are not completely sold on the method, I'll just try and code it now and you'll understand it a little better, I hope. So we are required to fill up this function called num_islands. Okay, and it has a return type integer. So what we have to return is we have to return the count of islands. So let me just declare a variable called count, and that is what we are going to return at last. So return count, I'm marking that as well. Now what we'll do is we'll have to traverse this matrix, as I said. So we'll have to find the number of rows and number of columns in this matrix, grid.size. So we are given a 2-dimensional vector and that is essentially a matrix. So n is equal to grid.size. This just gives the number of rows in the 2-dimensional matrix, and for the columns we'll just take the first row, that is grid of 0, that is the first row, and we'll find the size of it. So this will give the number of columns in it. Okay, so we have found the number of columns and the number of rows in the matrix. Now what we'll do is we'll traverse through this matrix for int I equals 0, I less than n, I plus plus, and then a nested for j equal to 0, j less than m, j plus plus. So this nested loop structure will traverse through every single element in the 2-dimensional vector. Okay, and what we are going to see is if the element is in fact the land area. So if grid of ij equal to 1. So they have given a character 2-dimensional matrix. So I am just giving 1 in single quotes. Okay, so if it is 1, we have to increment the value of count, denoting that we have found a new island. Okay, so count plus plus. After this, we are going to do the most important part. We are going to mark every single land area that is accessible from this land area with the 4 directions, in all 4 directions, and mark it as 0. Okay, now at this point I'll have to tell you some other thing, that is, in this particular question we have been given that the land area can be accessed only in 4 directions, but there is a variation of this question in which the land area can be accessed in 8 directions. So it includes the diagonals as well. We are not going to see that now, but it is just a simple variation of this program and it is quite simple as well. So if you follow this problem properly, you can be sure that you can do that as well. Okay, so what we are doing is we are incrementing the value of count and we are going to access all land area that is accessible from this particular land area in the all 4 directions and mark it as 0 as well. So we are going to write a function called mark0 and we are going to pass these values. the matrix of course and the current position ij. Okay, what this will do is this will mark everything as 0. Now we will write that function as well. So this doesn't have to return anything, so we will just define it as a void function, void mark 0, and it is going to have a 2-dimensional vector as argument, vector char ampersand grid int I and int j, I mean I first, j next. Okay, so we are going to write that function. Now before marking it as 0, we'll have to see if the value of I and j are in fact reasonable values, or the values that are inside the matrix. So if the value of I becomes -1, it will just produce a segmentation error, because grid of -1, 1 is not possible, right? So we have to check if the values of I and j are valid. So we'll have a couple of conditions for that. If I less than 0 or j less than 0, we'll just return. Okay, and the other thing is the number of rows and the number of columns. We know that from the 2D matrix, the I value and j value should be less than the number of rows and number of columns, because we are using a 0 based index. So if it is equal or greater than that, it will just produce segmentation fault again. So we'll have to see that they are less than that as well. So I'm just going to compute that again. N is equal to grid dot size. You can just pass it as an argument, but I'm not doing that right now. Grid of 0 dot size. Okay, so we have the number of rows and columns, and we have to check that I is greater than or equal to n, that is the number of rows, or j is greater than or equal to m. Those are invalid possibilities, so we are just going to go ahead and return. And now we have to do the important part. We have to see if it is 1. If it is 0, we can just go ahead and return, because it is already water and you are not going to reach anywhere from there. So if grid of ij equals 0, you can just go ahead and return as well, because you are already encountered water. From this you are not going to traverse through any other portion. Okay, it obviously means that your this island has ended here. So grid of ij equal to 0, we are just going to return. And now what we'll do is we'll mark this island or this land area as 0, because that is the reason we are writing a function, right? Mark 0 should mark elements as 0 and traverse through all the other elements that are possible, and should mark 0 as well. So we are marking grid of ij equal to 0. I just noticed that I have written grid of ij equal to 0 in digits over here, so I'll just make it as character. Okay, now it is right. So now we have marked grid of ij as 0. Now we are going to do the important part, that we are going to traverse the matrix in the 4 directions, and we are going to mark them as 0 as well. See, this mark 0 function can mark any index as 0. So what we are going to do is we are just going to call the mark 0 function with all 4 directions from the current node. So we are going to call this mark 0 function. It is just going to be a recursive function. So we are going to pass the grid value, and we will be passing the elements above this element, to the left of this element, to the right of this element, to the bottom of this element. So for that we are just going to modify the values of I and j. So for the element above this, the row count will be I minus 1, because it is in the same column but it is in the previous row. So I minus 1 comma j will be the element that is above the current element. So we are going to mark it 0. So mark 0 of grid of I minus 1 comma j. Now for the element to the left of this grid comma, it is in the same row, so I value should be the same, but it is in the previous column, so j value should be j minus 1. And now to the element to the bottom of it, it is in the same column, so j value should be same, but it is in the next row, so I value should be I plus 1 comma j. And now finally to the element at the right grid of, it is in the same row, so I value should be same, and it is in the next column, so j value should be j plus 1. So that pretty much is it. So we have found that this particular element is in fact 1 in the main function, and we have incremented the count value for that, and we have called the mark 0 function, which marks the current land area as 0, and it also traverses every other land area that can be traversed from this particular land area. So that will include the land above it, the land to the left of it, the land to the right of it, and the land to the bottom of it, if it is a land in fact. So it is traversing that and marking that to 0 as well. So that is what this mark 0 function is going to do. So I hope this will run perfectly. We'll see that now. I'm just giving run code. Okay, so the sample test case has been passed. I'll try to submit it now, and judging, it doesn't say if it is passed or not. Okay, 55 milliseconds faster than 7.4. Okay, so our code has been accepted. So hope you understood this logic. It is not that difficult, but I'm not sure if I made sense completely, so I'll just repeat the gist of it in a minute. You'll try to get a better understanding. I'm just blabbering at this point, so cut this particular portion. I don't know. Okay, so in the number of islands function, what we are going to do is we are going to traverse through every element in the matrix, and if you find a 1 in it, you will increment the value of count and call the mark 0 function for that particular position. So this mark 0 function will get this position, will mark it as 0 because it was 1, right, and we'll mark it as 0, and we'll call this mark 0 function with the values to the node above it, to the left of it, to the right of it, and to the bottom of it. So we are going in all 4 directions and marking them as 0 as well if they are 1. So at the end of this, if you found a 1, this mark 0 function will mark all the elements in the matrix that are accessible from this element through these 4 directions will be 0. So that basically is the logic of the program. So hope you understood this logic. This is a question that has been asked in companies like Facebook, Amazon, Netflix, and Google. So if you have any further questions, please let me know in the comments, and I'll get back to you as soon as possible. And if you like the video, please like the video, and for more videos like this, consider subscribing. Thank you so much for watching. See you in another video. Bye.